All right, everyone, welcome to this video. Our objective is that students will be able to interpret the meaning of slope in the context of a linear equation by demonstrating an understanding of a constant rate of change. Um, slope means a constant rate of change. It means something is changing at a constant rate. I'm getting $5 per day. A mouse is decreasing by 3 feet per second. I profit $45 per unit sold, etc. Right? Changes by the same amount each time. We have a positive slope when those two variables go up together, right? As I get, as I work out more, my stamina goes up, right? More working out, more stamina. Um, that's a positive slope. Both variables go up together. A negative slope is when one goes up, the other goes down. One goes up, the other goes down. That's a negative slope. So imagine how much I work out and my weight, right? As my working out goes up, my weight goes down. We have a slope of 0. That's just a flat line, and an undefined slope that's a vertical line. We won't touch too much on these today, but we want to really be able to tell the difference between positive and negative slopes. So again, a positive slope, the two variables increase together, all right? So, you can imagine it on a line. This is going up. You could say this is days, and this is, say, temperature, right? As the amount of days goes up, the temperature also goes up. A negative slope, say we had the same graph. Actually, let's just draw a blue line here. As on the blue line, as the days goes up, right, the temperature is going down. That is a negative slope. All right, let's dive right in here to example 1. We have a couple real life examples. We just want to look at them and label them as positive or negative based on our best thought. The amount of hours worked for a worker and their total money earned. So as you work more, you earn more money. As you work more, you earn more money. They go up together. That's going to be a positive slope. B, the age of a used car and its resale value. So this, you got to have a little bit of real life understanding of the world here. As your car gets older, does the car get more valuable or less valuable? Typically, it gets less value. I buy a new car, I drive it around for a little bit, it gets beat up, so the value goes down. This is going to be a negative slope. Now, you could make an argument that there are some exceptions to this rule, and I'm okay with that argument. All right, last one, the price of gasoline and the amount of people on the bus. And so this one was a little confusing when we did it in class, so I want to cover it. As gas goes up, less people will decide they want to drive because they have to spend money on gas, and more, maybe the bus is more worth it. So this would be, as gas goes up, less people are riding cars, so more people are riding the bus. So this would be a positive relationship as well. All right, go ahead and try the you-do on your own. Just quickly pause and assess these. Okay, hopefully you just finished the you-do. Let's go over your answers real quick. The amount of cigarettes smoked in life expectancy. As you smoke more cigarettes, typically your life expectancy goes down. So this is a negative relationship. The amount of minutes after a meal is finished cooking and its tastiness. So I finish cooking a meal, I let it sit, I let it sit, I let it sit, I let it sit. The amount of time that is going by is going up. What's happening to that tastiness if I let my I let my chicken sit out for 2 weeks? It's going down, right? So this is also a negative relationship. The number of customers in a restaurant and its daily revenue. Typically, the more customers you get, the more money you get. They're going up together. And so this is a positive relationship. Okay, so those are not too bad. Let's apply this thinking to write an equation that could be used to estimate the slope of company B. All right, so let's apply this thinking to some lines. The graph shows the relationship between a company's profit in time and months. Write an equation that could be used to estimate the slope of company B. Company B is in the red. Okay, so to find slope, I'm going to look for 2 points on the line. I have one here, and I have another one right here. So I want to write an equation that can be used to estimate the slope. So from here to here, we know an equation for slope is the change in y over the change in x, right? So from this point to this point, how much did my y change? Well, it looks like I went from 300 to 225. And so 300 minus 225 is 75. All right, so we changed by 75. Actually, let me show exactly. Whoops. All right, so I'm here and here. All right, again, slope change in y over the change in x. I just want to hit this exactly. I got the change in y by doing 300 minus, well, all right. I got the change in y. I'm doing this wrong again. Let's do a change in y over the change in x by doing 225 minus 300, right? This is where we ended. This is where we started. So the change is actually negative 75. And so to find the change in x, I'm really going, okay, I started at 0. I ended at 10. That's really 10 minus 0. Negative 75 over 10. So like this equation could be used to find the slope. Negative 75 divided by 10 ends up being negative 7.5. So the slope is negative 7.5. What does that mean? Let me clear this out. All right, so we have a slope of negative 7.5. And so that means every month they're going down 7.5 dollars in profit, or 750 in profit. So I'm not going to write that out, but just so everyone can hear it, every month they're losing $7.50 in profit. We know that because the rate of change, the slope, is negative 7.5. All right. This is the part where you do the you do. Go ahead and just pause and do it on your own first, and then we'll go over it quickly. All right, the graph shows the relationship between two cities' temperatures over multiple days. Write an equation that could be used to estimate the slope of city X. City X is in the blue. So let's do that. Let's just find the slope. So an equation. So we start here at 70. I'm going to look for another point. I don't really have one, so I'm just going to do some estimating. All right, so I'm going to go to right here. Oh, this is tricky. I'm curious what you came up with on your own. I'm going to go to right here, and it looks like in 10 days, the temperature went up about to 73. All right, so if I'm trying to find the slope, it's change in y over the change in x. It looks like the y changed 3 over 10 days. So the temperature changes 3 degrees over 10 days. That means it's changing by 0.3 degrees per day, right? 0.3. On average, well, not even on average, this is going up at a constant rate, we estimate, of 0.3 degrees per day. All right. That's it for this video. Ends with a little bit of confusion. If you have questions, feel free to find your teacher.